If you think about construction today, the uh, the traditional way we build things, it's just immensely complex.
Hmm.
You're looking at what is basically an outdoor factory, completely at the mercy of the weather, juggling maybe 50 different subcontractors.
It is the essence of what we call stick-built construction. It's an artisanal model, really.
Right. A craft.
And its timeline is, well, it's notoriously elastic. It's so vulnerable to rain, to wind, and completely dependent on getting skilled labor to show up to a difficult environment.
And the disruption to the neighborhood is just massive.
Yeah.
But there's this revolution happening,
A huge one.
moving construction off the building site and into the factory. It's a pivot, right? Treating a house less like a custom sculpture built in the mud.
And more like a high-precision product, something that comes off an assembly line. This shift to off-site manufacturing is exactly what we're diving into today.
Yeah, and to do that, we've drawn from professional industry learning materials. This is the kind of stuff construction managers are studying right now to retool their entire approach.
So our mission here is really to give you the foundational language, the vocabulary, to navigate this incredibly fast-moving change in the industry.
We're going to arm you with the key differences between the main modern methods, specifically prefabricated and sectional building. By understanding how they work, you'll see exactly why the industry is choosing factory-made over field-built.
Let's start with, I think, the clearest example of this industrial shift.
When I picture this revolution, the image that always comes to mind is a tiny home or some small building, completely finished,
Hmm.
being loaded onto the back of a huge truck, ready to just roll down the highway.
That image perfectly captures the whole concept of prefabricated construction, or prefabs, as most people call them.
It's like ordering something online and it just arrives.
Well, the definition is singular, and it's absolutely critical. A prefabricated house is built entirely in a factory. It is one monolithic unit.
So when it leaves the factory, it's done, ready to use.
Exactly. It's a single complete home.
That complete control, then moving the entire building process indoors. That seems like the ultimate solution for the quality control problems that plague traditional building sites.
It absolutely is. I mean, that's the whole why behind this shift. When you move manufacturing into a controlled environment, you remove the variables.
Right?
And the source material we looked at emphasizes two massive benefits from this.
Yeah, what are they?
Guaranteed consistent quality and precise workmanship. The assembly line process just standardizes everything, the cuts, the connections.
So we're talking about millimeter precision, not just,
Right.
close enough like you might get on a windy day on site.
Precisely. And the other obvious one is weather. If there's a blizzard outside, the factory work just continues, completely unaffected.
That's a huge economic advantage. No more weather delays.
It really is. I mean, the time savings are dramatic. A traditional build might take 6, 9, maybe even 12 months.
Or more, yeah.
A prefab unit, you can manufacture that in 6 to 8 weeks. That speed just dramatically shortens the capital commitment for everyone involved.
Okay, but if the whole house is one finished unit, that must create an incredible logistical headache for transport.
Ah, now you've hit on the major limitation.
You can't just haul a 3-bedroom house down a quiet residential street.
Exactly. That's the critical factor. Because it's delivered whole, you need specialized planning, you need wide load permits, careful routing.
So you're limited by the size of the truck and the roads.
You are inherently limited in the size and complexity of what you can build and ship, which is why you see prefabs used a lot for smaller homes, accessory dwelling units, that sort of thing.
So let's assume the giant house on a truck actually makes it to the site. What's the final process like?
Well, the on-site work is really just integration. While the factory was building the house, the site crew was preparing the foundation.
Ah, so they happen in parallel.
Yes. So when the unit arrives, it's just lifted onto those prepared foundations, and then it's connected to the local utilities, water, power, sewer.
So the disruption, which could have been a year, is now, what, a few days?
A few days of heavy lifting and connection work. That's it.
So the key takeaway for prefabricated is maximum off-site completion and incredible speed, as long as what you need fits on the back of that truck.
So if prefabricated is the complete ready-to-go product, we obviously need a method that can apply that same factory quality to larger, more complex buildings.
Right, like multi-story homes or apartment blocks.
And that brings us to our second method, sectional construction.
Okay, so this is where we're building things that are way too big for one lorry.
Yeah.
We're not talking about one finished box anymore.
No.
We're talking about what? Highly finished chunks almost like high-tech building blocks.
That's a great way to put it. The jigsaw puzzle approach is what some call it. The initial manufacturing is identical to prefabs. It's
Yeah.
all high-precision factory work.
But instead of one big unit.
Instead of one unit, the structure is broken down into large, pre-made sections or modules. These often equal entire rooms or segments of a floor.
And these aren't just bare frames being shipped out, right? If they're meant to slot together quickly, they must be pretty detailed.
Extremely detailed, but the materials we reviewed make it very clear these sections arrive with a substantial internal fit-out.
Like what?
I mean, finished interior walls, integrated plumbing, electrical wiring already installed and just waiting to be connected, insulation sealed in. They're engineered to just slot neatly into the next section.
That is a huge logistical advantage over a prefab. Shipping 4 large sections seems way easier than one giant oversized house.
It is.
But what happens on the site? Does that mean you have more on-site labor, and does that slow things down?
Well, it does increase the labor compared to a total prefab, yes.
Okay.
But it drastically decreases the labor compared to a traditional build. The on-site phase is really defined by heavy crane activity. You see the crane lifting, say, an entire second floor section.
Or a whole kitchen unit.
Exactly. And lowering it precisely onto the foundations or the section that's already in place.
So the crew isn't building the second floor on site, they're just connecting it.
They are performing precise mechanical and utility connections. The structural integrity, the fit, the finish, that was all guaranteed back in the factory under ideal conditions. This phase is far, far faster and less disruptive.
Let's talk about something that gets overlooked a lot. Waste. On a traditional site, you see these huge bins overflowing with offcuts and packaging.
A massive problem.
How does this factory model address that?
It completely flips the script. In the factory, waste streams are centralized and controlled. Any offcuts of timber or drywall are handled in bulk,
So they can be recycled or repurposed right there.
right on the factory floor. This hugely reduces that expensive, messy skipload of mixed debris you see on every single traditional site. Plus, because of the precision, there are just fewer mistakes and less wasted material to begin with.
So if we summarize the big distinction then, prefabricated is the speed demon for smaller units. It's built whole, delivered whole.
Right. Maximum offsite completion.
And sectional construction uses that same factory quality, but it divides the building into manageable, finished chunks.
Which allows for scale, for complexity, and much easier delivery. It balances that offsite precision with the need for a larger final building.
That distinction really clears things up. We've basically moved from building with materials on site to assembling products on site.
And that assembly model is the key takeaway here. These two methods, prefabricated and sectional, they really demonstrate this fundamental shift toward industrialization in construction.
Now, in the curriculum materials we reviewed, there was actually a third method listed as an aim for the learner. It was modular construction.
That's right. And it's an interesting point. While the goal was to identify prefabricated, sectional, and modular, the source material only really gave us rich, clear definitions for the first two.
So it's like a missing link in the source itself.
It is, and it highlights this fascinating tension in an industry that's evolving so quickly. We know the term modular is everywhere in these discussions. It often refers to standard, stackable, interchangeable box units. To be honest, sometimes they're almost indistinguishable from sectional units, depending on who you ask.
So the concept is critical to the future, even if the definition wasn't formally laid out in the introductory materials we analyzed.
Precisely. Our focus has to remain on the two clearly defined systems we just covered, but the underlying theme for all of them is the same.
Consistency and speed.
Consistency and speed. Whether a complete prefab home rolls in on a lorry or a dozen finished sectional apartments are craned into place, the driving force is solving those twin problems of cost escalation and delivery timelines.
Let's touch on that cost structure. With the traditional build, labor is something like, what, 40% of the cost?
Roughly, yes.
When you move that labor into a factory, does the price of the final house just plummet?
It's nuanced, but generally, yes, the cost is lower. The initial material cost might be a bit higher because of the precision engineering involved,
Yeah.
but the labor is significantly cheaper. It's industrialized, not craft-based. Workers are doing efficient, repetitive tasks indoors.
And the real money is saved on the financing, right? The speed.
That's the huge one. Cutting a 6-month project down to 6 weeks is a massive financial win for any developer.
So we're really talking about a complete inversion of how we build. We're trading unpredictable, high-cost field labor for predictable, lower-cost factory manufacturing.
Yes. And this is so crucial for you, the listener, to understand because every major developer out there is either using or exploring these systems as we speak. This isn't theoretical knowledge, it's operational.
This has been an incredibly clear breakdown. Let's just do a final recap to make sure those two core operational differences really stick.
Okay, let's think of it like a product catalog. The prefabricated unit is your small single-item order.
It's a turnkey solution.
Exactly. It's fully assembled, maximizes that offsite completion. It's built as one piece, shipped as one piece, and just connected on site.
And sectional is the solution for everything bigger. It gets you that same factory quality, but breaks the building down into those finished, manageable chunks.
Which allows the efficiency of the assembly line to be applied to larger, taller, more architecturally complex buildings that can just be joined together quickly on site.
Both methods just fundamentally challenge that old way of doing things.
They do. They prioritize reliability and quality control over the traditional weather-dependent and often delay-ridden process of building on site. This is the new industrial standard.
So here's where it gets really interesting for me. If we're seeing this fundamental shift from a craft model to a manufacturing model, what does that mean for the workforce?
A huge question.
If most of the building work moves indoors into factories, does that create a new labor dichotomy?
Absolutely. The need for, say, specialized factory engineers and assembly line operators goes up dramatically. But what about the traditional trades?
Right. Masons, on-site framers, roofers.
Do their roles diminish, or do they just pivot to become these highly specialized installers and finishing experts for the manufactured units?
Which leads to our final provocative thought for you to think about. If construction becomes completely dependent on these huge centralized production facilities, how does that change the resilience of our housing supply chains?
It's a trade-off.
We gain incredible speed and efficiency, but are we creating new single points of failure? If one massive factory shuts down because of a fire or, a labor dispute, could it stall the delivery of thousands of homes across an entire region?
The efficiency is clear, but that long-term systemic risk profile is definitely something worth mulling over.